everyone. I'm Mark Tewksbury, your host for this program. Our goal is to reveal the methods and materials that turn out the products we see around us every day. If you think you know something about these items, you might be in for a surprise. There's a whole world waiting for us to discover here on How It's Made. Why worry about light bulbs burning out when you've got spares? Well, today researchers are working on an eternal bulb made of gallium nitrate. It actually burns 5 times less energy than the incandescent bulb we've known since Thomas Edison's 1879 invention. I guess we're ripe for a change. On today's show, aluminum screw caps, chocolate, pills, and pasta. Okay, so it's not as sophisticated as uncorking a fine bottle of wine, but aluminum screw caps are airtight seals for bottles and jars, and they're recyclable. There are hundreds of everyday objects that are capped. This plant makes 250 million metal screw caps yearly in 12 different sizes. The caps are made from these 1 square meter sheets of aluminum weighing 450 grams. Some 3,500 thin aluminum sheets pass through this feeder. They begin by coloring the aluminum sheet with a colored varnish, a lacquer, and an ink. Then 12 minutes of drying is needed. The sheets that have been colored set off on a conveyor for drying. Then designs are produced. The coloring is applied by this varnisher. The aluminum sheets pass through the varnisher one at a time. Here we see the sheet printed. Above are the colors used. They are highly colored inks that adhere well to metal. Suction cups grab the sheets and send them toward the transport system of the punch press. This press will give the caps the required shape. But the caps have to be machined in successive steps by molds such as this one. The punches first cut the caps. Over 500 caps a minute can be produced. The blades of the punches are made of carbide, a very hard metal that can cut tens of millions of caps. At the exit point of the punch press, the caps are formed but don't yet have the right dimension. This stretching press performs the last 2 cold-forming steps so that the tube will have the required length. Now for the second stretching. This achieves the desired diameter. When the cap exits the press, it will finally have the desired dimension. At this point, the cap now has the required shape. The caps now have to be decorated to the client's requirements. The lateral imprint is made with this silk screen type decorator, which colors some 100 caps in 60 seconds. The decorator uses an ink specially formulated to adhere to metal. The caps will then dry in a warm air oven. The dried caps are ejected and fall into a container. This other flexographic type of decorator prints 155 caps a minute. Here we can clearly see the ink roller which imprints the side of the caps as they rotate against it in a steady stream. All that's required now is to form the cap and make the cut. The profiling and jointing machine makes the cuts and reliefs on 200 caps per minute. Machining the cap takes but a fraction of a second. They sometimes have to assure the water tightness of a container such as a wine bottle. For this, a polypropylene liner is inserted which hermetically seals the container. A check is carried out under a light to verify whether the cut has been properly made and the ridges well formed. At last, the final steps. This screw tightening machine hermetically seals the caps onto bottles. The 250 million screw caps made here each year call for the machining of 1,000 metric tons of aluminum. If you're young at heart, you might dream of working in a candy or chocolate factory. Oh, how sweet it would be. Well, at least for a little while. These delicious chocolate confections are made from melted chocolate flowing into molds. The master molds are first made of wood or plaster of Paris. They are then reproduced as copies in an epoxy material. To allow them to become flexible and give them the desired shape, the sheets of epoxy are first heated to 177 degrees centigrade. The epoxy sheet is then placed onto the original molds. The sheet is heated, then lifted off. Suction from a vacuum system makes it adhere perfectly to the shapes of the molds. Here we see the epoxy adhering to the master molds. Still hot and malleable, the plastic has to be cooled. A jet of compressed air effectively lowers its temperature. The mold undergoes a visual inspection to make certain of its quality. And now we move on to the chocolate. This melting unit, whose shell is fed by boiling water, is like a double boiler and melts 1,500 kilos of chocolate in 12 hours at 40 degrees centigrade. The ready-to-be-filled plastic molds are placed onto a conveyor. Filling is done automatically. Liquid chocolate runs directly into the molds. This particular machine produces 400 hearts a minute. The hearts are filled with a concoction of chocolate, cream, and coffee, which has been brewed for several minutes. It takes 20 minutes for the chocolate to set as the molds move along on this 9-level conveyor. Well hardened, the hearts arrive at the unmolding point. The molds are turned over and a rod lightly taps them on the bottom to allow the chocolates to fall out without being broken. Here the chocolates fall out onto a sheet. As soon as they've been emptied, the molds return to the starting point on the line to be newly filled. During their transport on the line, the chocolates complete their cooling and hardening. Now they're going to be prepared for packaging. Packaging depends on customers' preferences. The chocolates can be sold in bulk or placed into boxes. Here, 185 hearts are put into each box. Like the pure chocolate, white chocolate comes in as slabs before melting. Milk chocolate is often delivered in the form of 3-centimeter pastilles. Some chocolates are hollow. They have to be molded in 2 halves. These chocolate bears need special decoration applied by hand before the pouring of liquid chocolate. This decoration is made of white chocolate to which a colorant is added. In just 1 hour, they will make 1,200 bears. They're made by joining 2 hollow chocolate halves. The assembly is done using a refrigerated rotating machine. This machine turns the molds a full 360 degrees on 2 axes and vibrates the chocolates to prevent the formation of air bubbles. The chocolates rotate for 5 minutes before being sent to the cooling conveyor, where they will remain for another 20-minute period. And now they're ready. At this point, the bears are unmolded and they head off for packaging. Each year, this company processes 500 tons of pure chocolate. Many thousands of products are made here using 400 different molds in a variety of sizes. Take 2 of these and call me in the morning. Who hasn't heard that before? But how many of us, including physicians, really know how drug companies make pills? Medications are essential in the treatment of illnesses. It begins by a grinding process where the active ingredient in a tablet or pill is ground and mixed with a binding agent. The quantity of the ingredient needed to be ground is transported to the dryer in this container. Like all the other equipment, this container is made of stainless steel so as not to contaminate the product. The temperature of the dryer and the airflow are programmed with this interface. The granulation has to be dried at 40 or 50 degrees centigrade before being shaped into the desired tablet form. Molding of the pills is done by this press, which crushes the powder. The press exerts a pressure varying between 2 and 5 tons. Here's how the molding is done. The press magazine distributes the powder in molds made of steel discs. 2 stampers, one above and the other below, crush the powder and form the pill. Here the press operates at full capacity. It can produce 5,000 pills per minute. Quality testing is carried out on 5 pills every 15 minutes. Their hardness is verified with this apparatus in which jaws crush it with a force varying between 2 and 20 kilopascals. The pills must now be coated so that they won't crumble. A coating solution made of water and coloring pigments is used. This is the coating unit. It can hold 160 kilos of pills. 3 plastic tubes positioned at strategic points will spray the solution onto the pills in motion. The quantity of dry pills to be coated is put into the unit. Then the door of the coating unit is carefully closed. A drum turns inside the unit, tumbling the pills. Then nozzles spray the solution in the form of a mist, which quickly dries, preventing the pills from sticking to one another. This spraying operation lasts 40 minutes. Here we can compare pills. On the left are those made only of powder, while on the right are the spray-coated ones. The finished pills move down a chute to enter a counter prior to filling bottles. They are lined up in grooves to make filling easier. The quantity of pills to be placed into bottles is controlled by this automated unit connected to the counter. In this instance, 500 pills are poured into each bottle. This plant also makes capsules where the ingredient is not crushed but encapsulated in a gelatin casing. The distributor places the 2 halves of the capsules in the proper position for filling, with the wider half situated above. The top and bottom portions of the capsule are separated. The lower half is then filled with powder. When well filled, the 2 halves of the capsule are joined together. The completed capsules are then ejected from the filling unit. Then, via centrifugal force, they are positioned for the packaging process. The weight of each capsule is verified by this counter. Each capsule must have the precise weight. And the final step is packaging. A a sheet of transparent PVC is heat embossed, forming an impression to receive capsules. Then a pre-glued aluminum foil sheet is adhered to the backside, sealing everything in. This plant turns out millions of pills and capsules every year. This is what Italian traveler Marco Polo brought back from China some 700 years ago. Since then, pasta has spread all shapes and sizes, and so have we pasta lovers. But that's another story. Who would have thought that pasta is actually Chinese in origin? When Marco Polo returned to Venice in 1295, after spending 24 years in the Far East, he brought back with him Chinese pasta noodles. So quickly popular did pasta become that by the 15th century, it occupied a prime position in Italian cooking. In this same era, commercial production began in Naples. Italians today favor macaronis and raviolis with garlic and cheese. Pastas are generally made from semolina and water. These silos contain more than 30,000 kilos of semolina derived from durum wheat, a hard, amber-colored wheat. The semolina heads toward the high-speed premixer, where it will be vigorously mixed with water for 5 to 10 seconds. This machine can treat between 1 and 2 tons of semolina per hour. The dough is extracted from the premixer and falls into a first blade mixer, open to the air. Then the dough goes into this vacuum blade mixer. The mix is now ready to go through the brass molds. Here's a spaghetti mold and a mold for mafalda, very narrow lasagna. And here are molds used to make lined shells and stars for soups, as well as cresta di gallo. The dough is injected into the mold under pressure. This rotating blade machine cuts some 12,000 rotinis per minute. That's 720,000 per hour. With the dough being still quite fresh, the rotinis are soft. They will dry somewhat on this plate. Now we move to the lasagnas. The dough goes through this brass mold, and the strips of fresh dough, 107 centimeters long, are placed on these sticks to dry at 65 degrees centigrade. They dry vertically so as to retain their nice flat shape. After drying for 15 hours, the strips are then cut in 4, thus making 4 strips measuring 25 centimeters each. To minimize losses and make cutting the dry lasagna easier, scissors trim the dough pieces into equal lengths on the sticks. The long lasagna drying process begins. Once dry, the lengths of lasagnas are finely cut. They're now ready for packaging. To make some other pastas, the mix has to be a bit more worked in order for it to have the required shape. The dough goes through this roller, which gives it the desired thickness. And now butterflies are formed. This mold cuts 7,500 of them a minute, for a total of 450,000 an hour. The sheet of dough is 61 centimeters wide. It is produced in a steady stream and goes right to the cutting mold. The butterflies fall onto this conveyor to dry somewhat. Then they head toward the next production step. Certain short pastas, such as these butterflies and fuzzilis, have to be dried, so then they're put into this full dryer. Coming out of the dryer, the pastas are hard and ready for packaging. Here we see the ever-popular spaghettis being made. As with lasagnas, spaghettis are also dried vertically. Now this automated machine places the spaghettis onto a cutting table and breaks them to the proper length. The spaghettis are now ready for packaging. Exact quantities to be bagged are determined by computer. Then the spaghettis go gently down this chute. The amount of spaghetti going into each bag is transported and emptied out by this moving container. To make filling easier, the spaghettis are properly positioned by this chute. In just 1 minute, this machine can package 10 4-kilo bags. Whenever needed, it can handle up to 60 bags a minute. Pastas are a favorite meal the world over. This plant makes over 100 different products, and every day uses between 60 and 360 tons, or the contents of from 2 to 12 truckloads of semolina made from hard wheat. I hope you enjoyed our show today. We wanted to show you the behind the scenes of the world of manufacturing. I'm Mark Tewksbury. See you next time on How It's Made.